presenting the RAW Element Extruder, a game changer in modern construction. With a footprint over 3 times smaller than traditional systems, as well as eliminating the need for costly flipping tables, the system saves space and reduces expenses. This scalable system allows for additional units to run in parallel, preventing bottlenecks and ensuring redundancy in production. Advanced quality control is achieved through 3D scanning, creating exact digital replicas of each element. The system also comes with free online support, providing immediate assistance and updates. Ready for life cycle analysis and ESG reporting, the system gives you the data you need in the format you want. Finally, the system is versatile and flexible, primed for the shift towards green and state-of-the-art materials of tomorrow. These features collectively make the RAW Element Extruder not just a tool, but a comprehensive solution for modern, efficient, and sustainable construction. Now, let's discover the core components that drive the innovation of this system. First in line, and serving as the cornerstone of the system, is the RAW bridge. It features vacuum grippers that handle and position beams and boards, a milling tool for precise cutting, an inkjet marker for essential markings and instructions, a camera and 3D scanner for quality assurance, calibration, and data gathering, and finally, a horizontal nail gun and a vertical staple gun ensure secure and reliable fastening. Additionally, there is the option to include a glue gun to enable the RAW bridge to glue boards together. Next is the RAW floor bridge, which is essential for precise assembly from below. It's equipped with a staple or nail gun for fastening and a vision system for accurate alignment and quality assurance. Then comes the vacuum cutting table, strategically designed to hold boards and elements in place during milling or assembly. The system is completed by the beam destacker and cutter, which enables autonomous picking of wooden beams directly from the pallet. Coupled with the ability to execute precise cutting, its capabilities facilitate the handling of various beam types used in the construction of wall elements, installation layers, as well as floor and roof elements. Finally, the system includes a material zone for storing materials utilized in the element extrusion process. The RAW bridge is equipped with a scanner capable of scanning these materials. The data gathered from these scans, when integrated with the continuous processing information, becomes invaluable for life cycle analysis and ESG reporting. Now let's take a look at the actual element extrusion process. First, a plate is picked from the stack and positioned on the first vacuum table. Subsequently, a wooden beam is picked up and placed into the beam destacker. In the destacker, the beam is securely held in place by a smaller, embedded vacuum table. Next, the beam is precisely cut to the required length using a circular saw. Once cut, the beam is rotated, preparing it for pickup by the gripper and vacuum grippers on the RAW bridge. Any surplus wood from this process is discarded into a designated waste bin. The cut beam is then precisely placed onto the plate. In a coordinated process, the RAW bridge holds the beam steady, while the RAW floor bridge simultaneously fastens the plate to the beam. This tandem operation ensures that the beam is not only held straight, but also securely fastened in its correct position, guaranteeing precision and stability in the assembly. After the RAW bridge has moved the plate and beam into a new position, the beam fastening cycle repeats. This repetitive process ensures a consistent and efficient assembly, maintaining high standards of accuracy and stability throughout the construction. At a certain stage in the element extrusion process, the introduction of a new plate becomes necessary. Accordingly, a new plate is fetched and, optionally, glued to the existing one, though this specific action is not depicted in the video. The two plates are then securely fastened together using a wooden beam, strategically placed at the joint between them. This method ensures a strong and seamless connection, enhancing the structural integrity of the assembled element. Now, let's fast forward to the stage where all beams have been precisely fastened to the bottom layer of plates. It's important to note that the beams at the top and bottom are securely fastened to the existing beams using the horizontal nail gun. Also, take note that the bottom plates have been cut where necessary, as exemplified by the door opening in this instance. During the extrusion process, the entire element is 3D scanned. This advanced scanning creates a digital replica of the object, serving as a key component for quality assurance. Subsequently, various pieces of crucial information, such as vapor barrier time, insulation time, and other key locations, can be marked on the elements. Additionally, both beams and plates can be milled as required, allowing for customized shaping and fitting. This precision in milling and detailed marking reduces the likelihood of human errors. After insulating the element, which can be done either manually or autonomously with a raw bridge equipped with an insulation tool, the next step is to add the top layer of plates. The top plates are then securely fastened to the beams using the vertical staple or nail gun. Now, let's fast forward to the point where all plates have been securely fastened to the element. At this stage, the inkjet marker comes into play once more. In this specific case, it applies a unique identifier to the element. However, recall that the marking can also be used for providing instructions for the next stages of construction or installation. The final step in the extrusion process is the milling of the top layer of plates. For this particular element, it involves cutting out the space for the door opening in the plates. With the cutout for the door now finished, the element has been fully extruded. This marks the completion of one work cycle, and it is now ready to extrude yet another element, showcasing its versatility in constructing various structures, whether they be walls, roofs, floors, or other similar elements.